share a presentation on friction, safety, and durability of pavement markings. So thank you for joining us. I'm going to introduce our speakers. We've got Ethan Peterson from MnDOT Department of Traffic Safety. We've got Mihai Marstino of the University of Minnesota Department of Civil Engineering. And we have Tony Kutsky from the City of Woodbury. He's their city engineer. So I'm just going to tell you a little bit of background about the CTS councils. We provide a forum for transportation professionals and researchers to exchange information on current transportation issues and trends. And we bring together university faculty and staff with practitioners from the public and private sectors to recommend direction and participate in improving the center's research, education, and engagement programs. So Sam is going to share a link in the chat shortly if you'd like to read more about the different councils that CTS has. So we're going to go ahead and have our speakers go in the order you see them here. We're looking forward to your participation, but we're going to have you hold it till the end. So you can go ahead and put a chat in the chat, put your question if you want to get it off your chest and get it out there. But then we'll go ahead and go through those at the end of the three presentations. And you can also raise your hand if you'd like to verbally propose your question at the end, and then we'll call on you and unmute you. So just a couple more things before we get started. If you would like credits for this presentation, we are offering an hour and a half of professional development hours for CPAs, or CPAs, not CPAs, AICPs. And there'll be a PDH form in the chat if you'd like to take advantage of that. We do have one more research webinar this fall that you might be interested in, and that is going to take place on Monday, November 20th at 3 o'clock. And the title of that presentation is Towards Implementation of Max Pressure Signal Timing on Minnesota Roads. If you'd like to sign up for that webinar, you can get there by going to CTS's website. Under Events and Seminars, you're able to register. And one more thing, we would just like to know if there are any students on the call today. Please go ahead and put your name in the chat so that we can track the number of students that participate in our events. And you can just send that to all panelists. So a brief introduction of the presentation. Pavement markings, which contain glass media to provide retroreflectivity, are often slipperier than surrounding pavement markings and pavement. The sudden difference in friction between the pavement and markings can create a safety hazard for pedestrians, bicyclists, and motorists, especially in wet conditions. New products for pavement markings and colored pavements that provide additional friction have become available and show evidence of being durable. This webinar will highlight University of Minnesota research that investigated the friction differential between the new products and the surrounding pavement. The project involved performing skid resistance testing on a number of products, using different testing devices, and providing guidelines for evaluating the frictional characteristics of pavement markings and colored pavements. So I've already introduced our speaker, so I'm going to turn it over to Mihai to get started.
Thank you, Beth. Let me share my screen here. Right, so thank you for the introduction, I would like to thank CTS for this opportunity to present our research. We have not completed our research, so we were not able to finalize our last task of providing recommendations, and the experimental work is in progress, but I believe we have a lot of very interesting findings, some results that could be very valuable for our future work and also for our speakers, and I'd like to our attendees, and I would like to thank our attendees for taking time. I know everybody's really busy, and I'm happy to see quite a number of people attending it. I would like to start by acknowledging the research team. So I am the PI and had the pleasure to work with Larry Zanko from NRRA Duluth. Actually, he just retired. And our research scientist, Mughal Turash, on this project. And as Beth mentioned, the frictional characteristic of pavement surfaces obviously are a major safety component, and pavement markings are necessary because they play an important role in traffic flow and safety, not related to skid resistance. However, due to the requirement of improved retroreflectivity conditions for night visibility, they tend to be slippery because of the, in general, glass bits that they contain. And of course, as you can imagine, the sudden change from a normal pavement surface to pavement markings without any warning, and this can also happen with colored pavement lanes, this can create a safety hazard for pedestrians, for bicyclists, and particularly for motorcyclists, especially under wet conditions. So I think we all agree with this statement. And what we try to do in this research that was championed, by the way, by Ethan and his colleague Sonia. We started it a few years ago, and we are still working on it. So the main goal is to understand what's happening to address the gap in when you see the transition from a normal pavement surface to special surface condition, and also provide some solutions. And of course, the way we always start our research efforts, we look at what other people did, learn from what they did, don't want to repeat what other researchers have done, and also come up with new ideas from this literature review. And we performed an extensive one, both national and international, and I'm going to talk a little bit more about the international component later on, because we think that would provide a lot of useful information for any implementation activities at the end of the project. We also try to find available data, not generated by us, but by others, and also conducted a local survey to understand the people perceptions on this issue. And of course, part of the research plan was to perform skid-resistant testing on a number of pavement marking products, traditional ones, and some with improved skid resistance performance, using also different testing devices. And this is still in progress, and Ethan will discuss more about it. I'll just introduce it briefly. Our hope is, based on all the results, on our findings, our hope is to provide guidelines that could be used on a regular basis to evaluate frictional characteristics of these unique pavement surfaces, pavement markings, or colored pavements. And we performed a literature review. We found a number of various good resources. However, because I don't have time to discuss all of them, I would like to discuss one particular reference, which is from more than 40 years ago. It's from my own university, Penn State. And the authors are J.J. Henry and Dave Anderson and Gordon Hayhoe. I had the pleasure of working with Professor J.J. Henry as part of their skid resistance surface characteristics group. And also Professor Dave Anderson was my PhD advisor. He's also responsible for, those of you who know about materials, the PG specification for asphalt binders as part of the SuperPave. But anyway, it's not for this reason I selected them, but this is a heck of a study, I have to say. A lot of experimental work, both in laboratory conditions as in the field. A lot of things, valuable findings there. Of course, the materials 40 years ago are different from what we use today. So we couldn't use too much of the material characteristics, but nevertheless, the conclusions were are still very valid. So just to give you an idea about what they did, the study, they had 39 formulations of 11 different types of marking materials, both laboratory and field conditions in the field. At that time, they were able to use the standard lock wheel test. Actually, this test was developed at Penn State. And in the lab, they used a number of devices, among them the British pendulum test that we are also using. And what they found out, and which I think is still valid, most likely today on current materials, none of the marking materials, the pavement marking materials, approach the control surface friction, the unmarked ones, even after 9 months of exposure. So basically, they remained with low skid resistance for an extended period of time. And some of them were so low that they thought that if they were applied, the authors thought that if they were applied large areas, they will clearly be a safety hazard. Also, they tried, and I guess this would be one of the goals of research in this area, to establish allowable levels of marking material skid resistance. However, they were not able to do that because they didn't have enough experimental data, and also because this involves analyzing complex and variable nature of human behavior. So if they couldn't recommend a specific number at that time, in spite of all these materials tested, so they suggested that further studies are needed for driver behavior and data from accidents occurring on marked roads. And they also concluded something that I think most of us, I think, would agree to this conclusion, that motorcycles are more affected by this friction differential than drivers of four-wheel vehicles. And some of their conclusions, some of their findings actually are reflected also in what we see later on in more recent research. What I have to say, which is kind of interesting, but also we still have this issue. We don't have a lot of data relating, accident occurrence with pavement marking. So the data is very limited, as you will find out. So we try to do that after 40 years from this project, and the only historical crash data we found was from Federal Highway Administration. However, this database has just a limited number of records, very few involving accidents and things like that. It was mostly related to motorcycle. We did an analysis, so we were able to download the data from FHWA, and we did some statistical analysis, but we couldn't find, because of limitations of the data, we couldn't find significant factors to clearly show what is influencing, in this case, number of fatalities. Also, we looked at a more recent synthesis report, also done by Federal Highway Administration, but the Office of Safety. I communicated with Georgine Jerry a few years ago, and they also found significant gaps in the design, friction needs, and motorcycle-specific concerns. And in this report, they also provided a few recommendations. Among them, one that we also followed without knowing about their report, using dynamic friction tester and British pendulum tester for systematic testing of frictional characteristics, because they're easy to use. The locked wheel test device obviously requires very large strips of pavement markings and, of course, traffic control and so on. They also suggested this innovative detail for pavement markings for crosswalks, designed to avoid the wheel path. As you can see here, here's the wheel path, and this is the crosswalk pavement markings. And they show this as an example. All right, so next what we've done was, okay, so we're talking about that. Let's find out what users, bicyclists, pedestrians, motorcyclists actually think about this problem. And we performed a survey. It was focused more on the local community, but we were also able to get information from bicyclist and motorcyclist groups and various transportation and engineering organizations. We surveyed our department, our students, our faculty, our staff. I have to tell you that we have many of our staff and faculty and a lot of students doing a lot of biking. I was quite surprised to see how active we were. And basically, we had 3 separate surveys, so the set of questions were different for pedestrians, for cyclists, and motorcyclists. And I'm going to show you briefly some of the results here. We have it published as a task report in a lot more detail, but this is just a snapshot of what we have found out from the survey. So this is for biking. So when biking on surface with pavement markings, did you notice any changes in friction when transitioning from bare surface to pavement markings? The blue color is yes, even in dry pavement conditions. The orange one is just in wet conditions. Then the yellow just in wet icy conditions or no. And you see that there are a number of yes responses here. If you add, both dry and wet, and here it's just in wet conditions, and most of them are under normal ride, not a big difference under accelerate, but you see a big difference in brake when you are just in wet conditions. And there are very few responses related to colored lanes. That's why you see this bar chart here. When asked whether they or someone else slipped on surfaces with pavement markings, participants primarily mentioned painted markings during icy or wet conditions, especially while turning or braking. So that was something that many participants mentioned. In terms of motorcycles, the same questions, and these are the answers. You see a lot more yes here, both in dry and in wet conditions. Most users mentioned that lane markings, markings at the intersections, and crosswalk markings were the most prone to cause slipping. And again, smooth and painted markings were the ones responsible for most of these events. In terms of joggers and people who walk, we have here a plot that shows on what kind of surface they walk or run. And you can see, of course, us Minnesotans, it doesn't matter. 80% responded that on dry, wet, snow plowed, ice covered, it doesn't matter. They keep doing it. And we also ask if they're able to comment on whether they or themselves or someone else they saw slipped on any pavement markings. And many users mentioned crosswalk markings. I am aware of a few cases among people I know, but they mentioned also that this happens on bare pavement surfaces while slippery in icy or wet, or where slippery in icy or wet conditions. So not in this case, they did not single out just the markings, it was just the crosswalk. Maybe this is also due to the fact that people are rushing, trying to cross very, very quickly, and this is what happened. All right, so we found a number of interesting information about what's going on. While we were doing this and looking at what other people have done in terms of skid resistance of pavement markings, we found out later on in the project a very good resource, also through communications with colleagues from Scandinavian countries. And I'm going to spend a little bit of time on this certification system that is used by Scandinavian countries. That's called Nordic Cert, because this is, we found out, the most comprehensive research and the most detailed process for certifying road marking materials. So, and we thought that we could get some very good ideas from what the Scandinavians are doing and hopefully apply some of that to our own certification system if we ever develop one. So this was developed for road marking materials and includes the countries of Denmark, Iceland, Norway, and Sweden. So this started some time ago, more than 10 years ago. They, based on conversations among the researchers and engineers, they found out, they decided to establish test fields. They all agreed to where to have these test fields. So they established that in 2015. And they have new materials that they are testing out every year since then, and also measuring the properties. As of January 2023, this is the last information we got from them. They were able to test 560 materials from 25 manufacturers. So it's quite impressive. And I like this idea of this certification system, and that's why I had it in italic here. So they developed it with the idea to promote fair competition, promote better development and new, better materials, increase knowledge, obtain better documentation, and improve road marking quality. This is not just for skid resistance. Obviously, they are looking at other properties also related to safety, of course, retroreflectivity being one of the main ones. So they proposed guidelines on materials for both longitudinal and transverse markings. Among the certification parameters, they included color, type 1, what they call a flat, and then a type 2 that have properties that enhance retroreflection in wet conditions, inlaid markings, anti-skid materials, and so on. If you are interested, I encourage you to visit their website. There is a lot of very useful information, more than I can present here. But it's quite interesting to see how they started to think about this a long time ago, and now they have a good system in place to look at these materials. We also found a number of additional documents once we got to the Nordic cert, published by the Swedish National Road and the Transportation Research Institute, the VTI, and Danish Road Authority. And some of them, as I mentioned, we think can be used to develop something similar, maybe even better for our conditions. These are pictures taken from their website that shows the test sites. They are located in different countries here. So that's how they look. They look a little bit different than ours, as you can see. And basically the way this works, they perform some performance measurements. So they apply them and they carry out measurements 2 weeks after applications, and then they keep monitoring them for durability after 1 year and after 2 years. All measurements are performed in the direction of traffic. All measurements are in dry weather and on dry markings, of course, except friction, because friction is not too bad when it's dry, but it's really affected by presence of water, so wet conditions. There are a number of parameters that they measured, but mostly retroreflective luminance and luminance coefficient under diffuse illumination, and so on. And of course, friction. So when we did our literature review, we found a lot of research that was focused on the retroreflectivity properties, but very little research done on friction of pavement markings. So this was one of the very few that had this incorporated. They had a very clear way of measuring the skid resistance. So they measure it on wet markings like everybody else, but they have developed their own portable friction tester, the PFT. This was developed by a Swedish company called Coralba, and it was the result of a lot of work performed at the Swedish National Road and Transport Research Institute over the years. During that period of time, they found some very good correlations between this device the Coralba device and the British pendulum test that they used prior to the development of this particular testing device. We have been in contact with them. We thought at some point to get such a device, but communication was not that great, and also the device is quite expensive, and we did not include it in the budget of the project, but maybe later on we can revisit this issue. So we also found out that there are a number of new developments that I thought would be worth including in the project, and maybe something that could be used also in our situation. So they developed a different type of road marking that have this unique profile that combine the benefits of and performance of flat and structured type of markings. You can see it right here. And they have high wet night visibility because they have this particular structure, but because they are flat at the surface, they provide low noise and vibrational levels. So, and because they are not flat at the pavement surface, they drain the water from the pavement marking during rain, and this, according to their ads that they put for this particular product, the response time of motorists improved by up to 50%. So basically, you improve your skid, your braking ability quite a bit. What I found also very interesting, this idea that in areas with very good nighttime lighting, such as downtown intersections, for example, where you have ample lighting and it's not very dark, you don't really need these special retroreflective properties that actually diminish skid resistance properties. So maybe for these particular areas, you don't need to include this type of material. So just pavement markings without retroreflection could provide, a good solution, because they will also have good skid resistance. So those were the things that we found quite interesting and something to think about for future research. Once we finished, getting all this information, of course, we moved into the next phase of our project, the one where we hope to get the very meaningful information that will help us select the best products. And this is to perform actually friction testing on various pavement markings. And our initial thought was to do testing with the British pendulum tester, maybe the most widely used, very portable. Of course, you just measure a tiny little bit of the surface of your pavement marking, but still you do this repeatedly, you can get some good information. Since it's the way the rubber boot and the pavement surface interact, the speed is very low, when you get this friction measurement. So this is more representative of skid resistance experienced by pedestrians and bicyclists. Of course, our hopes were with a dynamic friction tester. This device has been proven to be an excellent device for determining friction properties. It has been developed many years ago. I remember early 1990s meeting with the Japanese engineer who developed this product. He was trying to do some measurements at Penn State research facility there. But now is one of the most widely used devices, very simple, very portable, and can do actually measurements at different speeds, which is really important. So this was the other device we had in mind. And then we also thought of using these sources ASFT T2Go friction tester available at one of our laboratories at St. Anthony Falls. And this was specifically designed for friction properties on sidewalks and road markings. We had big hopes on this device. For various reasons, as I'll tell you, we were not able to use it. So we did a lot of preliminary testing. Some was done on campus at University of Minnesota. And we found out very good correlation between the British pendulum and the DFT results. We found a very similar trend in a testing performed for a different project near Duluth. My colleague Larry Zanko is the PI of that project. And they were investigating the use of taconite aggregate as lower cost alternative for a high friction surface treatment to replace calcined bauxite. And we did a lot of friction testing there as well. And we found out that BP and DFT results correlated quite well, and also have had additional confirmation from measurements done by the locked wheel testing. So they were able to also do locked wheel testing measurements. So we are very confident that British pendulum and DFT are basically reasonable, reliable results. We are not sure what happened with our T2Go device, but our results were not reasonable. We found that the results were very different than the other two devices, and we decided not to use it anymore. So we ended up just using the British pendulum and DFT result. These are some of the locations for our preliminary results to make sure that the devices we are using, we get, as I said, reasonable results. So this is a location on campus. This is the location in Duluth, near Duluth, actually. So based on everything that we've done so far, we decided to then move ahead with our testing campaign and perform friction testing on a number of pavement marking products. Since traffic control is such a big problem, we decided to actually contact our colleagues at the Main Road facility and perform all these testing, apply the pavement marking products at Main Road facility and test them there and keep monitoring them. This approach has a number of significant advantages: minimal traffic control, if any, different pavement surfaces available, if you know about the various test sections at Main Road, and of course, possibility of long-term evaluation for skid resistance and durability, and possibly doing retroreflectivity measurements as well. And I'm just showing you a picture here of the low volume road at the Main Road and some of their test sections, but we were able to do that. And Ethan was instrumental with tremendous help from our colleagues at Main Road facility. Ben and Jacob and Jeff, they were of great help, and we were able to do that. And I will stop here and let Ethan, who was responsible for all this nice work now done at Main Road, to tell you about what was done there. So thank you.
Thanks a lot, Mihai. I will take over here. Okay, I think we're up and running. Somebody wants to, it looks like Mihai's nodding. I'll take that as it's good to go.
It is.
Okay, perfect. Thanks, Mihai. I'm Ethan Peterson, and I'm the pavement marking and crashworthy engineer here at MnDOT Office of Traffic Engineering. And I'm going to go over just kind of the background, why this kind of came to be very quickly, and then also go over a lot of the material installations as we kind of mimic what we've been using and also what we've been looking at, like using into the future, some stuff we've demoed, different techniques. We were lucky enough to get a contractor on board to install a number of things and a couple different manufacturers to get out and get on Min Road's low volume road here. And yeah, we'll just jump right in here then. Wait for this. So why, right? Why is always kind of where we start. And Mihai went over this already, but I'll briefly run through this as well. So the problem really is that pavement markings can decrease friction of a pavement, especially in rain. I think we've all seen this. We've all been pedestrians. We've for sure all been pedestrians. All probably biked through this stuff, and you know, it's really becomes a safety issue for what we're calling vulnerable road users. So motorcyclists, bicyclists, and pedestrians, when they're traversing these intersections with these pavement markings or colored pavements. And kind of some background, within the last few years, MnDOT has introduced some skid resistant markings, and it's mainly with an aggregate. I think a lot of it has been a preformed thermoplastic product for the most part. We'll kind of go over the materials. We have a flow chart and such next, but the goal of this really is to help establish our material specifications for pavement messages and colored pavements revolving around skid resistance. We really would love for these pavement markings and colored pavements to match the friction of the pavement they're on. I don't know how many are familiar, but apparently F1 racetracks, they really put a lot of effort into making all those pavement markings match the surface for all the same reasons we're looking to. The current practice for MnDOT has been established through our provisions for pavement marking operations technical memorandum. And I'll just highlight the section that talks about skid resistance. So this isn't exactly it, but it's just a section of it. So enhanced skid resistance is recommended for any situation where deceleration, turning movements, or pedestrian and bicyclist traffic is occurring. So examples of this would be crosswalk blocks, pavement messages and roundabouts. Roundabouts, a big one. Bike lanes that utilize colored pavements, railroad crossings, stop lines, stop ahead pavement messages. So that's kind of where we're really pushing for getting these skid resistant pavement markings out there. And I'll admit we're kind of in our infancy of this. So this is a great, I think this project's going to be a really great starting point. You know, we're already calling something out. We don't know what our specification should be. We have a number, and we really want to see if that's going to meet our needs. And here you can see the flow chart that's in that tech memo for pavement messages. You look at bituminous, you can kind of just follow along. We've got an expected longevity for each of these markings, and then we just kind of call out each of these pavement markings. I won't go through them all, but feel free to Google this, and you'll be able to find it pretty quickly.
Ethan, there was a comment that you are not in presentation mode. Could you switch, because we see both your next slide?
Oh, I must be okay.
I know your Zoom is not your.
I apologize about that. Here, I might have shared the wrong screen. That's my bad. Tell me if this is correct now. Yeah, I've got
Ethan.
What's that?
That looks good.
Yeah.
There.
Okay, I thought I had it. Apologize for you guys seeing not as clean of a presentation here. We'll pick up here. And I apologize if you hear my dog. Somebody just showed up at my house, I think. A delivery, I'm sure. Perfect timing. Anyways, let's jump to the field testing here. Looking at this, we looked at 10 different variations of both typical products, mainly typical products, but also some things with newer spins on them. You know, the things we altered and messed with were the materials. Typical stuff you see in Minnesota are latex, epoxy, pre-floor thermo, and we've started demoing a lot of MMA or methyl methacrylate. It is not mixed martial arts. That would be interesting to apply to a pavement. And then also looking at the aggregates that you can switch into this. What we messed with were the beads. We looked at corundum and taconite. And then, as said before, these were tested, and these were tested on the low volume low volume loop on Min Road, and they were installed on both bituminous and concrete. Like Mihai said before, it was awesome to use Min Road because there was no traffic control necessary. There's one truck that makes a round all day, and all we had to do was call him off, and there wasn't any traffic. So that was great. And then, as you can kind of see here in the pictures, you can see what we were putting down was a 2-foot by 24-foot swath. We avoided the center line markings and edge line markings as much as we could, just to kind of preserve those. And this low volume loop is actually going to see traffic only on one side, and then the other side will actually see just plows. So as stated before, the testing devices are going to be the DFT and the British pendulum. So kind of some of the nitty gritty here. There's all 10 items here. And I can kind of rattle these off really quick. The first thing we looked at was a latex with an AASHTO M247 type 1 latex, type 1 bead. Second one is the epoxy with the type 1 bead. Those are pretty typical installations when not looking at skid resistance for the most part. And just wanted to make sure we get those in as a type of control. The third one is an epoxy with the type 1 bead and a corundum. We actually did some layering in some of these, and that one was layered. So there was one layer with skid resistance, that skid resistant corundum, and then on top a mix of beads and corundum. And your number 4 is a epoxy with beads and taconite, same kind of layering approach there. That fifth one you see there is an epoxy with a crushed glass product. So from my understanding, it is a recycled glass that kind of gets crushed to not exactly a super pointy characteristic, but it definitely is skid resistant. It has a pretty aggressive feel to it. Some of these do. The sixth one is a bike lane type preformed thermoplastic, and that actually doesn't have any enhanced skid resistant items in there, just beads. And our 7 is preformed thermo with enhanced skid resistance, so that has beads and then also some, I believe, corundum in that one. Number 10, and you'll see that there's a gap there. We actually skipped 8 and 9 because on 8 we had a concrete joint. As we were laying all these out, we kind of put extra numbers out, just knowing that we would see some possible defects in pavement. And number 9 actually had some refractive cracking that we didn't want to put anything over. So we skipped right to 10, and that is the methyl methacrylate with beads and corundum. Again, it's kind of a sandwich layered method. And 11 is beads and taconite, and then 12 was MMA with a crushed glass product. So that's all of our samples. And just kind of for fun, it's always exciting to see things get installed. These don't have any volume. There was quite a bit of wind that day, and the machines are pretty loud, but I'll at least run through some of these installations. So this first one, oh, that one started. The third one, I don't know why. So number 3 here, that is an epoxy with type 1 beads and corundum. And actually what you're seeing get put down, sifted on, is the corundum through that little bucket. You'll see there are different methods to adding aggregates in this one. The second one here is actually MMA. That is an MMA with beads and corundum. And right here, you're seeing the corundum get spread through a pneumatic sprayer. And this was pretty neat. It looks like, I mean, it puts out a really even distribution compared to, hand casting or that sifting technique. Although the sifting technique, for how rudimentary it is, it does pretty well. This third one is a preformed thermoplastic. You can see I'm torching it on, and it's always kind of neat to see. This is the portion that hasn't been heated yet, and this one is heated. And then this last one is actually sample number 9, and this is an MMA with taconite. So they actually hand casted that on. That aggregate was a little bigger. I think we would try a little smaller gradation next time, although it is definitely going to give us some good skid resistant characteristics. And then I think that's pretty much it on what I wanted to go through here. So I really appreciate everybody showing up and taking the time to join us here. And as you can see, my information is here. Feel free to email or give me a call if you would like to further discuss some of these items. Otherwise, I'll turn it over to Tony.
Thank you, Ethan. Some great videos there and great products that you're testing. So interested in seeing how all that comes about. All right, hopefully you are seeing my screen now.
We do.
Yep.
All right, excellent. Well, again, I'm Tony Kutsky, the city engineer for the city of Woodbury, and I want to bring a little bit of a local perspective on some of the research that's being done here and what might be planned and used here in the future by local agencies from this research. From a very high level, I want to talk about pavement marking implementation that we have at the city level, and then some of the resident safety concerns that we hear related to pavement markings and skid resistance. And then also specifications, standards, and policies, and how we develop those and how we might be looking forward to address some of the concerns that we hear out there in the public. First off, the city level and public works departments are installing, maintaining, and replacing pavement markings on an annual basis, whether they be standard painted lane lines, epoxy lines, pavement messages for bike lanes, turn arrows, those types of messages. There are applications of bus lanes with MMA that are also being introduced in our networks. And many different products. There's a lot of products available. You could see from some of the research that Mihai had talked about, and also that Ethan has presented here. Many products, many different variations, and different treatments that can be done to try to get durability, and also retroreflectivity, and also our skid resistance in the products that we use. So one thing that we've heard from residents at times is that these pavement markings we put down do result in concerns for safety for skid resistance. Luckily here, these photos shown on the screen are stage photos of some great actors that we pulled aside to prepare for this presentation, but they are a reflection of some of the concerns that we hear, whether it be pedestrians walking in the areas, and the crosswalk markings that we put down, or bicyclists who are using our networks on our roads and our trails and encountering these pavement markings and noticing that skid resistance, especially when they have turning movements over those markings. Now, we've often looked at durability, because some of our resident concerns are when these pavement markings start to wear, their impact and visibility and certainly effectiveness tends to also go away with the pavement markings disappearing. But also this skid resistance is something that's been a concern of residents within the city. We also have advocacy groups who are looking for ways to increase safety in the roadways, and oftentimes pavement markings are one way to do that. We want to ensure that when we add pavement markings, they don't result in additional concerns from users related to, now we have great visibility of pavement markings, but now we have a slip resistance issue. So We often spend a lot of time in the past here really focusing on durability, and our public works departments and industry wants to ensure that we get the longest life out of these, but haven't looked as much on our skid resistance and our resistance to slipping as a material performance in our specifications. So if we can address those concerns and also help with the partnerships that we have with these local advocacy groups, we can help meet the requirements that we have of the city to get durability, but then also address concerns of all these advocacy groups and the users in the network for skid resistance. So at the City of Woodbury, we update our specification manual on an annual basis. We know that there's a lot of technology and changes throughout the industry that result in us taking a fresh look at our specifications every year. When we do that, our pavement markings, we have not in the past really given much focus on the skid resistance of pavement markings. And based on the research and recommendations that will come out of this study, we do anticipate taking a closer look at that and understanding what kind of performance specifications we can create for pavement markings related to skid resistance, and also ensure that we're still looking at our durability. So material selection is extremely important. There are, as we mentioned earlier, a lot of materials available, and the specifications, if we put a focus on those skid resistance performance criteria, it may help us with our material selections. Also, research often sparks additional research, and we like to keep an eye out on developing standards, and those often will help guide future research, but then also guide shifts in our industry to focus more on the skid resistance and as we have with durability in the past. So we like to consult the industry, understand the development of those new products, and use that information to inform future decisions that we make as we start to look at our specifications. Research and new data also helps us from a standpoint of guiding policy document preparation. City of Woodbury just recently developed a bicycle and pedestrian plan. It was really focused on commuting and recreational use of bicycles within our transportation networks. From that, it had a large focus on how to provide engineering design, education, and enforcement for a lot of components of our users that are either walking or biking in our networks, with additional information and data related to skid resistance from the research. We can certainly also add components to the plan for the skid resistance on those pavement markings, so that the application of those don't result in those unintended consequences with slip hazards. The City of Woodbury is also under construction right now on a number of our roads with a new bus rapid transit project. The Metro Gold Line is about halfway done with construction. Through that application of the dedicated bus lanes on the project, we anticipate seeing some installation of MMA pavement markings to identify those bus lanes. Those result in very large square footages of pavement area that have pavement markings, and those are high demand areas for biking and walking to those transit stations. So we want to ensure that the products that we use and the application of those products result in safe surfaces that will not result in slip hazards. So at this point in time, I think we turn it back to Beth for the question and answers.
You are correct. Thank you, Tony. So we do have a question here, a couple actually in the Q&A. Bob Job asked, has chip seal work both pre and post pavement markings been considered? Any of our panelists have thoughts on that? Or Tony, have you seen that maybe in application?
There's no doubt that chip seals increase the skid resistance of the pavement, and application of pavement markings on top of them can still maintain those. It depends on the products that you have. So that's something that could be looked at further.
Good question. Jonette Kunau, we have some projects with significant amounts of MMA. Does Ethan have any preliminary recommendations for the type of aggregate?
Sure. I think we've been doing this, and actually we haven't been calling out specifically, although we've taken into account a Mohs hardness of, we spec out something, an aggregate that has a Mohs hardness of 7 or greater. So that would be something like a taconite or a corundum, and those are the two aggregates that we've seen in MMA. So.
Thank you. And another question here from Alfred Haugen. Would application of hydrophobic coatings on pavement markings reduce the slipperiness?
Great question. I don't know. I mean, we have been using or applying hydrophobic coatings, but I guess regarding removal of snow and ice. But yeah, I don't know what that does to pavement markings. That's a great question.
Thank you. Those are all the questions in the chat. So does anyone else have one for the chat or want to raise their hand, and we can unmute you to ask the question? So Bob asked, another question from Bob Job, glow in the dark markings versus beads.
That's an interesting question. Beads are more durable from what I've seen. Preliminarily, I know that I've seen glow in the dark pavement markings and looked into them a bit. I know it's gotten used, I think in Denmark, I think is where I've seen them, where the big like photoluminescent markings have been. And from what I understand, the durability just isn't there. It wasn't able to last very long. So we're not jumping on that yet. I think I've seen some research being done in one of the more western states like Montana or Utah. One of their labs is trying to develop something that might work that's glow in the dark. But at this point, beads just have a far better longevity. So
and I would imagine
that's why we're going with that.
Applying salt and all sorts of other things on our pavements. I don't know what they would do to the glow in the dark ones, so markings. So, good question.
They keep coming. Jonette, again, how did MnDOT apply the MMA on the test road? Was it sprayed or squeegeed on, or maybe a different method?
Yeah, good question. It was actually applied as a flat spray, 98-2 flat spray MMA. And as I kind of glossed over, it was installed in layers. So there's first a 30 mil layer, and that had the taconite or corundum put into it, and then the second layer was a bead blend, or I think they mixed in some corundum into the bead blend with the one with corundum on it. So, and I guess if you're interested too, we do have a demo spec that I could, if you reach out to me, I can send you kind of what our demo spec has been at MnDOT, and you can take a look at that, and we can talk a little bit more too, for sure. MMA is definitely a hot topic now. It's getting used more and more. So we're kind of at the beginning stages. We've used it for a year or two in demo projects, maybe 3 years now. And from what we've been seeing, it's very durable. Have one district that's really liked putting it in roundabouts. That's been one of the most challenging locations to have any pavement markings, just because there's a lot of shear force that goes through with all the turning movements that we encourage through those. So pavement markings do get tore up quite a bit in there. So we're starting to move toward MMA in roundabouts, and we've been seeing it wearing really well.
Great. Bob loves questions. Thank you, Bob. We appreciate the questions. Is there any concern with glass beads being released into the environment? Probably better than plastic.
It is. I know there is always a hazard evaluation process we go through. So our environmental services looks at everything that gets put out there, and based on that, there's not a huge concern, but obviously we don't want them to just flood beads everywhere, push them into the ditch. That's always a concern for any product, right? Whether it's hazardous or inert, we don't want to throw it out into our ditches, into our waterways and such.
I have one for Tony. Maybe this is something that's coming, but I know with more pavement markings as time goes on, you might start to see the need to add more money to your pavement remarking program or send people out there more often. Have you noticed that, or do you think maybe that's something you'll have to plan for, maybe with Gold Line?
Yeah, I would agree. I think that our capital improvement plan does look at pavement markings as a portion of that. It's certainly a component that I think every city would need to look at. Pavement markings are important in our network, and it's one of those pieces of infrastructure assets that we need to ensure that we're planning for replacement of. Durability has certainly been our number one concern over time, and getting that longevity out of them is important. I can bet that right now, the wear that we've had on some of the pavement markings, that from a visibility standpoint, we can certainly see them and wouldn't replace them, but from a skid resistance standpoint, we may have found that they've reached the end of their life. So,
thank you. So we got another question here. Paul Moser asks, has there been any testing done with aggregates added to latex? And if so, how well does the aggregate hold up within the latex?
In this project, we did not look at anything other than latex with beads in it. But it would be very interesting to take a look at high build latex and some of these aggregates in the future. Yeah, I think this was actually what we call our high solids latex, not the high build latex, which is a more durable latex. So as things progress, we want to look at more and more. It's just as we started this, it was overwhelming to think about all of the combinations you can do with binders and aggregates. So definitely interesting, though. I mean, latex just, I guess in general, doesn't hold aggregates and beads as well, but I know that is definitely it's definitely something that we'd like to look at in the future.
Great. One more. Pete Dunleavy, are you looking into any stamped in materials, such as to create the appearance of bricks or other grid-like patterns?
And as a part of this project, we are not. I will say that I think most of those products don't have any sort of skid aggregate that goes in, or any sort of retroreflective media. And in general, I know MnDOT doesn't use that, so I'm not super familiar with it. I know that type of stuff is somewhat tough to organize with so at one time we used to do some inlaid tape, and that was really hard to do because you had to line up your pavement marking installers with your pavement installers and pretty much be right behind the pavement rollers, right behind the the pavement that's getting put down, because it does take a very specific mat temperature to put that stuff in. Otherwise, you have to heat up the material again and press it in. So that's the very long-winded answer of saying we don't use it, and it didn't really get looked at in here, although definitely something that I'm sure will get looked at in the future. I think this is, I will add here that there's not a lot of research on friction of pavement mark messages and different materials. So this is kind of just the beginning of it, because I know there is a bigger NCHRP project that I believe is funded, and it hasn't really moved anywhere yet, but it will be looking at basically the same thing, and I anticipate that it'll rope in a lot more materials. So
Thank you. Alfred Haugen mentioned he's not sure, but maybe hydrophobic coatings would increase visibility of markings and reduce slipperiness because the grime would not adhere to the surface and the water would be repelled.
I don't know, but it will be an interesting experiment to try. So, yeah, good idea.
Great, last call. If anyone has a question they want to type or raise their hand to be unmuted. Seems like that's it. That was great. Thanks for all the questions, and thank you for the answers, panelists. We do have one last thing here. We don't want people to jump off because we do want to see if anyone has any comments for our round robin. We're just going to ask a few questions, and really anyone who has anything to contribute, it would be wonderful. You can type it in the chat or you can raise your hand. But their questions are: what current infrastructure issues are you or your organization facing? Do you have any organizational, informational, or event updates to share? And ideas for future council meeting topics or presentations or speakers. So any of those, feel free to raise your hand or type in your question or your comment. We'll certainly take any of those pieces of feedback after this meeting as well. We're always looking for good topics like this one that will generate as many participants as we had today. So, and feel free to reach out to anyone at CTS. All right, well, it doesn't seem like anyone wants to chat anymore. So thank you very much to our three speakers, Mihai, Ethan, and Tony. And thank you to CTS for sponsoring.